welcome back. Last lectures we discussed about the folds, and now another one which is left out in the structural geology part is the fault, which it is extremely important. And first of all, we will learn about the different type of faults, and as similar to what we have discussed in folds, we talked about different parts of folds. Here we will talk about different parts of faults and how we classify the different faults. Maybe it is quite possible that we will try to finish in this module, but we will try, if not in this module, we will try to finish in the next module. So, faults are extremely important, and we will learn how different type of faults are classified here. Okay. So, as we have been talking about that we have the folded landforms when the area is subjected to tectonic deformation under compression. So, what basically you will see is that you will see in combination of anticline, and you will see the along with that you will see the synclines. Okay. So, these folded layers of rocks or the sediment successions are will be seen in form of anticline and syncline. Now, all rocks or the material of the earth have some elastic limit, okay, and after that if the threshold limit crosses, it will break, or what we call it will fracture, and that fracture will result with the displacement. So, that displacement will what we call along the fracture plane where the displacement is taking place is termed as fault plane. Okay. So, this fault, different type of fault planes or the faults we will talk about. Okay. So, let us move ahead in this course now. This is how rock deforms. This we discussed in one of the lecture, that if you are having that like this is an undeformed cylinder which has been shown here, then you keep on pressing it, you have the fracturing, and so this is a kind of a brittle fracturing, but at some locations, like if you are having this, you are taking putting the same material in the deeper part of the earth, then you will have different type of deformation. It will not really fracture in the sense. So, the earth crust is a very brittle part, and that usually fractures along the weak zones, and these weak zones we term that as in faults. Okay. So, this is under the condition representative of a shallow crust. Okay. Like for example, this is the marble which has been shown. So, it will break, okay, because it is brittle in nature. But under the conditions representative of deeper crust, okay, the marble will be in ductile form. Okay. So, it will deform in a ductile form, it will not fracture as what we see near to the surface. Okay. Now, I already discussed about this part, that if you move into the deeper part of the earth, the deformation which you see will be uniform, okay, and then where we expect a uniform stresses, okay, but on the surface we have directional stresses. Okay. So, we have sigma 1, sigma 2, sigma 3 where we if we define this, then we are having the sigma 1 is the maximum, then we are having intermediate sigma 2, and we are having sigma 3 is the minimum one. Okay. So, the deformation will be maximum along the sigma 1. Okay. So, that what we call differential stresses. Okay. So, due to the differential stresses, we have different type of faulting or fracturing which has been seen in the rocks. Okay. Now, development of different textures in rock, this we have already discussed. So, I will just move ahead. So, please refer to your previous slides when we were talking about the igneous rocks getting converted into the metamorphic rocks. Okay. This also we have discussed to some extent, okay, that if you deform the material, so under you keep on increasing the stress, you keep building up strain. Okay. So, you have the energy which is getting stored. So, initially the energy will be stored elastically, and finally it will break. Okay. Before that we have some deformation which will be in ductile form. Okay. So, there will be in deformation in a ductile form, but finally or eventually it will break, and this is your earthquake. Okay, this we have discussed at the time of when we are talking about the interior of earth also. Okay. Now faults, if we define, is or the fault is a fracture in a rock along which blocks of rock slip past each other is known as fault. Okay. So along a fracture, if you see any displacement, okay, then you will term that as a fault. Okay. But that displacement may be related to the earthquake, or may be related to the deformation, or it may be just on gravitational also. Okay. So that we have to be extremely careful how to differentiate that. Okay. But anyways, well, if we in a proper sense, if we take any displacement in a rock layers, or maybe stratas, or the sediment succession, will term that as a fault. Okay. And faults mainly occur as a zone, okay, what we call the fault zone. So it will not be in single line or single plane of fracture, but it will be having multiple, and it may have a wider zone. Okay. And surface along which the block of rock slip is called fault plane. Okay. So this we will see the part when we are talking about the parts of the faults. We'll talk about that. Surface expression in form of elevated cliff, okay, exposed at the surface due to faulting is termed as fault scarp. So these are all terms which are extremely important for us. Okay, the fault zone, fault plane, and the fault scarps. So surface manifestation is termed as fault scarp. Okay. So during deformation, there will be or during an earthquake there will be displacement, and that displacement is reflected on the surface, and that surface expression is termed as fault scarp. Now naming fault, basically what we see in field or on the surface are named and classified on the basis of, one, the dip of the fault plane, okay, in which direction the fault is dipping, one. Second is that is, one is the amount of dip, sorry, and then another is the direction of dip, in which direction that fault plane is dipping. Then we talk about the sense of offset. Okay. So whether the block has moved up or block has moved down, or whether the block has moved, or it has passed by each other laterally. Okay. So we determine with the help of this the component to establish mainly the direction of displacement, in which direction the fault moved. Okay. Then the sense of displacement, as I was talking about, that up and down, we can also measure that. The amount and magnitude of displacement, how much it moved. Okay, it moved from meters, or it moves in feet, or it moves in centimeters, that you can make out. Okay. So again, as we discussed in the strike and dip, okay, what we did in the strike, that we had like if this is strike, then this what we are having the this we are having, like for example, if we have the inclined plane like this. Okay, so we have so you have the strike here, and this will be the dip direction, and this will be with respect to the horizontal. You will have the amount of dip and all that. Okay, so this is the amount. Similarly, we also try to look at the offset. Okay, and then we measure the amount of displacement, direction of displacement, and the sense of displacement. So now we will see what are the different type of faults and how we classify those. Okay, so just keep in mind that what we have taken about the strike and dip, because we are going to use some of the parameters which we used for measuring the strike and dip. And so this all parameters are related to slip, which is the actual relative displacement, and on the basis of the sense of slip, the faults are categorized as strike slip fault and dip slip fault. Okay. So either the displacement is along the strike. Okay. If this is the strike, so displacement is the movement is along the. So if you look on the plan view, you may be able to make out that in which direction the block has moved. Okay. So these are the two blocks, say A and B. So the movement here, what we see is that this has moved by this amount. Okay, so you can make out that in which sense the block has moved. Now this is along the strike, so this will be the strike of the fault. Okay, this we are looking at the plan view. Now along with this, that we will also come across that there will be a slip along the dip of the fault plane. Okay, so we are having, for like what we were talking about the bedding planes, we also have the fault plane along with the displacement will take place. Okay, so based on this we can classify the faults, either they can be categorized as strike slip or dip slip faults. So parts of fault, again very much similar to what we did in the dip and strike, and then further we talked about the parts of folds. Here there are parts of fault, different faults. Okay, so we have different terms, and those are either respect to the horizontal or respect to the vertical. We try to collect the maximum information of the displacement, the sense of displacement, amount of displacement, and all that. Okay, so first coming to the heave, here the H is denoted as heave, and now this is the horizontal component of the dip separation. Okay, so if any movement which is taking place, suppose you are having there is a fault plane here, so if anything moves, then there will be a horizontal component of the displaced plane, and that will tell you that how much the land has moved, okay, or shifted sideways. So that is the heave. So the heave is over here, this is the heave which we will measure. Okay, so this is with respect to this is a horizontal. Now coming to the throw, that is T denoted by T, which measures the vertical component of the dip separation. So this is the throw which we are getting here. Okay, so heave is this one here, we have heave, and the next is what we are having, T is the throw. Okay, that is an vertical component. Then comes the head. Okay, head is this one over here. So head is the angle of fault plane with respect to vertical, as we were talking about the dip, which is respect to the dip is here, this is the dip here with respect to horizontal, but this angle is with respect to vertical. Okay, so these are the components which you measure when there is a displacement along the fault plane. Okay, so what has been shown in this figure is that this block, okay, this is which is marked by green. Okay, that was once together. Okay, it was together. So the green one here, this is A and A, and this one we mark. So this were together, and then during an earthquake it moved down. Okay, it moved down. So it moved along the along a particular depth, and this portion here we will call this as an fault scarp. So we will see some signatures of this type of features, what we call fault scarp in ground on the ground. We have some field photographs, I will show that. Okay, so for us it is extremely important to know the angle, at what angle the fault is dipping, how much is the horizontal separation, how much is the vertical separation, and what is the net slip, okay, which has occurred along this one. Now coming to the strike, that was an example, but I'll talk later also. This is an example of normal faulting, okay, what we call normal faulting, where one block moves down with respect to another one. Okay. Then coming to the faults which are taking place in strike slip faults. So let us talk what are these different type of strike slip faults. Now strike slip fault that accommodates horizontal slip between the adjacent block along the strike. So if you are having particular strike along that, you will have, so if this is the strike, so the movement has been seen taking place along the strike. Suppose the movement has occurred like this here, so this block has moved in this direction with compared to this one. Okay, so this block has moved in other direction. So with the sense that where you are standing, okay, with this you will say that which block is moving. So this is your right. Okay, so this is the right hand side and this is the left hand side. So this is been termed as right lateral strike slip. We will talk about this very quickly in the coming slide. So, in short, the strike slip faults that accommodates horizontal slip between the adjacent block along the strike of the fault. So, the strikes of the fault will be somewhere here. This will be your strike of the fault. So, dip slip faults again are the faults that accommodates translation or slip upward or downward along the dip of the fault plane. So, either the block has moved up or either the block has moved down. Okay. So, in short, if I sketch here very quickly, then we are having this is the fault plane, and one block has moved down with respect to the another one. Okay. So, you have this block which has moved down. Okay. So, this is A, this is A. So, one is this one. Another one, if you look at, for example, then we are having a block here now, which is so here what you see is that this block, okay, has moved up with respect to this one. This we cannot say that there is a movement. Okay, we will talk about that what has happened here. So, here this block has moved down, here this block has moved up here. Okay. So, these are the different movements which are taking place, either the block has moved upward or either the block has moved downward. Okay. So, that you have to keep in mind, and then which has been used for the classification of the faults. Okay. So, one classification is of the dip slip fault is your normal faults, okay, which we termed as a normal fault, and the normal faults can be of different angles, okay, which can vary from say 40 degrees to 70 degrees, and those which are having dip less than 45 degrees are referred as low angle normal faults. Okay. So, similarly, we have thrust faults also. Now, normal faults are usually seen in an extensional tectonic environment. So, this is an extensional tectonic environment, whereas the thrust and another one which is a reverse fault, these two are seen in the compressional tectonic environment. So, this is one major difference between these two, and in normal fault what you will see is the block, one of the block will move down with respect to another. Okay. So, this is very much important, which you have to remember, but we will go in detail as in the coming slide. So, one we are having the normal fault, another we are having thrust fault. Now, thrust fault and reverse fault both are in compressional tectonic environment, but the difference here is only in terms of the angle. Okay. So, you have, if the fault is dipping less than 45 degrees, then they are usually termed as the thrust faults. Okay. And if you are having the fault angle greater than 45 degrees, then they are termed as reverse fault. So, in these two fault type which are of compressional tectonic environment, the block will move up with respect to one another. Okay. Whereas here in the normal slip fault, the block will move down. Active faults are very important because these are the faults along which we believe that the next large earthquake will occur. Okay. But in terms of the definition, if we take the active faults are faults along which the movement have occurred, that is the displacements have occurred during last 10,000 years. Okay. So, you remember this with the time scale, geological time scale, this is what we are talking about within the Holocene epoch. Okay. And likely to occur in near future. So, you are expecting an earthquake along that particular fault line. Okay. And the active fault is the manifestation of crustal deformation by displaced landforms on the earth's surface. So, this is what we are looking at on the earth's surface. Okay. So, we try to identify the manifestation of deformed landforms on the surface. Okay. So, these are the remnants or the signature of ancient earthquakes, and that is what we call the study of earthquakes, paleo seismic. So, paleo is ancient, seismic is earthquake related phenomena. Okay. So, this is the definition of active faults, along with the movement occurred during last 10,000 years, likely to occur in near future, that is, a movement is likely to occur in near future, and what we see is the manifestation of crustal deformation on the surface in form of displaced landforms. Okay. Now, this importance is because they are considered to be the source for the large magnitude earthquakes in near future, and it is required because this is one of the vital information or the which is taken for the seismic hazard assessment. For so any area which is seismically active, so for seismic hazard assessment, active fault information is extremely required. Okay. So, this is one of the reason for the why we want to identify the active faults on the surface. Okay. So, fault slip is the response of stresses, either we talk about the extensional stresses, compressional or lateral shear. Okay. So, in almost all geological situations, what we consider the stresses are mutually perpendicular to each other. Okay. So, if you are having like talking about the here the sigma 1, sigma 2 and sigma 3, this is the maximum one and the intermediate and the minimum one, depending on that where the maximum stress is acting upon and where the minimum is, you will find the different type of displacements. Okay. So, in reverse, the maximum stress is along this direction, okay, and the minimum is at the top here. So, this is sigma 3 here, and we are having sigma 1 along the fault plane, and minimum is along, that is sigma 2 here. Okay. Similarly, here you are having the maximum is at the top, okay, that is sigma 1 in the normal conditions. Okay. So, this what we find is that where the block has moved down with respect to another one, and then we call this as a normal fault, whereas here we are having the reverse fault. And then third one, the maximum stress is again in an oblique fashion, but along the fault plane here. Okay. So, this is again what we see, the movement along the strike. So, they are termed as strike slip faults. Okay. So, this you can refer and try to understand this and remember that how different stresses are important in classifying the rocks also, or sorry, in classifying the different type of faults here. So, style of deformation under different stresses. So, if you have the tensional one, then what you are doing, you are stretching the crust, okay, and you are thinning the crust in one or the other form. Okay. So, you are thinning the crust here, and then what you see is a type of faulting is the normal faulting. In another one, you are compressing. Okay. So, you are shortening the earth crust. Okay. And what final results you are getting is, you will see either the reverse fault or you will see the thrust fault formation. So, either you are having the reverse fault or thrust fault, and of course, before faulting or the displacement, you will see the area is under compression resulting into folding. Okay. And then third one is the shearing part. Okay. So, shearing, you are again putting very oblique things and shearing or twisting the area. So, you will have the bending in the layers resulting into strike slip motion. Okay. Now, either the block will move in this direction or maybe in the opposite direction, okay, depending on the stress conditions. Okay. So, these are the different patterns which you should remember. So, you are having tension, you do stretching, and you are having thinning of the crust. When you have compression, you are doing shortening and you are thickening the crust here and folding. Okay. And then you are shearing, you are twisting the crust. Okay. Now, here is the one of the beautiful example of the fault scarp from California, and this what you see here is the fault scarp which has displaced the landform. Okay. So, let us see what are the faults, different type of faults and the signature. So, here if you carefully watch, one block is moving or passing each other, okay, with respect to another, and this is what we termed as a strike slip fault. Okay. So, this block has moved in this direction, whereas this block is moving in this direction here, and then slip is taking place somewhere along this plane. Okay. So, this is a plane here. So, what you see is the displacement lateral displacement along the strike, and this is termed as right lateral strike slip fault. Okay. However, no matter where you are standing, if suppose you are standing here, okay, and then try to see the fault, then also you will find that the right block is moving towards your side, hence you can classify this as an right lateral strike slip fault. Okay. So you can talk about this. Okay. So the strike slip faults, as we have discussed, they accommodate horizontal slip between the adjacent block. Okay. Now this one is, again, this is an fault plane here, along which the movement has occurred, the block has moved down, and the strike of the fault is over here like this. Okay. This one is the strike. Okay. And this, what you are looking at, which is coming up, is the fault scarp. Okay. So now this is the type of dip slip fault along, because the movement is taking place along the dip component, and one block is moving down the another. We are doing stretching, hence we term this as a normal fault. Okay. This one is reverse fault, where one block is moving above the another one. Okay. So we see this as an reverse fault, and this type of faulting is seen in the compressional tectonic environment. Now this one is very typical, where in the previous one, if you see, you are able to see the displacement between this. If you take the grayish layer or the brownish layer, they are broken and they have been displaced. Okay. Whereas in this one, the displacement is seen below the earth's surface, but on near the surface, just the folding has been seen. So no displacement or the breaking up of the layers are been seen. So such type of faults are termed as blind thrust. Okay. So where the displacement has not been able to see the surface, remain blind, hence we term this as an blind thrust. Okay. Now this one is having two different components. Okay. But the combination of those two components we can see here, and these are termed as oblique slip faults. Okay. So we have the left hand side, what we are able to see, that there is an oblique, there is a slip along the strike also, and there is a slip along the dip component also, there is a slip, whereas here again it is slipping along the strike here, and you are having a reverse component, the block is moving up. Okay. Now as I told in the beginning that we may have the additional module of this, because the application part of the fault is extremely important, and application of other geological structures and what we have learned regarding the rock types and all that, we will try to talk in the application part of earth sciences in civil engineering in the next module. Okay. So I stop here, and we will see you soon in the next module, which will be coming up in couple of months. It will be announced, and hopefully we see you all again. Okay. Thank you so much.